Okay, so that integration limit is 0 to t. So if you integrate it, it was on my minus 1 by lambda natural log of, if you integrate and substitute that limit, obviously it will be t minus lambda n first, then we'll substitute that limit. Limit is 0 to n, and this will be your dt. Integration of dt is t. Okay, so if you substitute that upper limit, so it will be now let us bring that minus lambda that side. So it will be, if we substitute that upper limit n, so it will be simply t minus lambda n. Okay, now if we substitute 0 here for lower limit, so it will give, this term will be 0, so simply it will be minus ln p, and that should be equals to minus lambda t. What does it mean? It means, so ln b minus a, or a minus b equals to ln a by d, right? B, right? So it will be p minus lambda n divided by p equals to minus lambda t. So it means p minus lambda n by p equals to exponential minus lambda t. Okay, so lambda n will be how much? Lambda n will be simply p minus p exponential minus lambda t. So it means that n that is asked in question, that will be p minus p exponential minus lambda t divided by lambda. Is it clear?
Yes, sir.
Okay. Now we'll do 3-4 more problems. Shall I erase?
No, sir.
हो गया? Shall I proceed for next problem?
Yes, sir.
Okay. You finished, right?
Yes, sir.
Okay.
Yes, sir.
Now next problem. So there is a nuclei cesium-137. Okay, its half lifetime is given, T half equals to 30.08 years. Okay, 1 milligram sample, 1 milligram cesium-137 is prepared on 1st January 1980. Okay, then they ask its activity that is measured 1st January 2021. So they ask this activity. So this 1 milligram cesium is prepared when 1980 1st January. Though, so what will be its activity of 1 milligram cesium that is measured on 1st January 2021, and they have given you that half lifetime. Okay, did you understand that problem?
Yes, sir.
Okay, so let us first calculate how many number of nuclei are present in 1 milligram. Okay, so that will be your n naught. So how many will be there in 1 milligram? Okay, so 137 gram will contain 7 gram
Avogadro.
Avogadro number, 6.023 10 to the power 23. So 1 gram will contain how much? 6.023 10 to the power 23 divided by how much? 137, right? Okay. Then 1 milligram will contain how much? So 6.023 10 to the power 23. 1 milligram means 10 to the power minus 3 gram, right? Divided by 137. Is it okay? Is it okay?
Yes.
So this is your N naught. This is your N naught, right? Because 1 milligram was when it was in this time when that is prepared. So this is your N naught. Now activity is how much? So activity. So activity means AT equals to N naught lambda exponential minus lambda t. Okay. So N naught is you got, that is 6.023 10 to the power how much? It will be simply 20, right? No. 10 to the power 20, right? Minus 10 to the power 23 minus 3, 10 to the power 20 and divide by 137. And what about that lambda? How much it will be? How much it will be? 0.693 divided by half-life is how much? 30.08, right? So it will be 30.08. Then you have to convert into day. So years to day, you have to multiply by 365. Then from day to hours, so you have to multiply by 24, right? Then hours to second, so you have to multiply by 3600. Is it clear? So always when they
Yes,
used
sir.
to ask that activity, so always they used to ask you in seconds. So whatever time is given, you have to convert it into seconds. So 30.08 years means
सर दोनों चीजें ईयर में तो लिखी है सर वैसे
कहाँ पे? नहीं,
सर
यहाँ
वो जो
देखो देखो ये यहाँ पे कोई प्रॉब्लम नहीं होगा, यहाँ पे आपको यार,
यस सर
बट यहाँ पे देखो ये आपका एक्चुअली दिस विल गिव यू द dimension of this. Exponential power is always dimensionless, but here problem. So this will give you that decay per time. So this time will always be in second. Now you can
24 into what you have written, sir.
24 into, so see 30.08 years means you have to multiply it by, if you multiply it by 365, it will come to days. Then days to hours, so you have to
Hours.
multiply it by 24. Then hours to
seconds.
seconds, you have to multiply by this factor. Then exponential minus lambda t. So whatever you are saying, that is correct. Now I'll write it in DR. So 0.693 divided by t half. T half is how much? 30.08. Now time will be how much? So this is in years. So I have to write this, that time should be in years, so that it will be cancelled. Did you get what I'm saying? देखो यहाँ पे आपका 0.63 by 30.08 ये क्या था? years में था. तो ये जो टाइम है आपको years में लिखना पड़ेगा, तभी ये years कैंसिल हो जाएगा, है ना? प्लीज कीप इन माइंड. So whenever you are writing the dimension, exponential or sine cosine, so that dimension should be, it should be dimensionless. So यहाँ पे अगर आपने यार सब्स्टिट्यूट किया, यहाँ पे यार कितना यार्स होगा? वो टाइम कितना यार्स है? 1980 से 2021.
41 सर.
ग्रेट. 41. यहाँ पे स्टूडेंट ने मिस्टेक किया है ना? ये क्वेश्चन था, ये 40 किया है सब लोगों ने वहाँ पे. ये कितना आया है? कितना आएगा? So if you calculate it, it will be 1.24 10 की power 9 DPS. DPS मतलब?
decay per second.
Good. So DPS means decay per second, or you can write becquerel also. Okay. Shall I proceed for next problem?
Sir, side is not clear, sir.
Sorry?
Side is,
नहीं दिख रहा है?
yes, sir.
कौन सा
It's
part?
not clear.
This part?
Exponential part.
Oh, exponential part. ठीक है. सो एक्सपोनेंशियल पार्ट ही लिखना पड़ेगा ना, बाकी तो आपने सारे दिख रहा है, ये इतना दिख रहा है आपको?
Yes. Yes, sir.
ठीक है, मैं यहाँ पे लिख देता हूँ आपका एक्सपोनेंशियल जो पार्ट है आपका, तो ये फैक्टर आपको दिख रहा है, ये वाला लिख रहा हूँ मैं, एक्सपोनेंशियल -0.693 डिवाइड बाई 30.08 इंटू 41। बाकी दिख रहा है ना?
Yes, sir.
ओके
Thank you, sir.
ठीक है, चलो इरेज।
Yes, sir.
ओके, नाउ नेक्स्ट प्रॉब्लम। Suppose you have potassium 40 that is present in human body only how much percent? 3.24 into 10 की power minus 5%।
सर ये लास्ट क्वेश्चन का आंसर क्या आया था?
1.24 into 10 की power 9 DPS।
1.24
सर फिर आपने ये ब्रैकेट में करके e टू पावर क्यों ऐसा लिखा?
ब्रैकेट में ये जो फैक्टर है ना, ये सारे फैक्टर,
यस सर।
वो ब्रैकेट में मैंने लिखने के लिए बोला हूँ।
सर
ठीक है।
10 की पावर कितना है सर?
हाँ 10 की पावर
10 की
9
पावर कितना था सर?
9
ओके सर।
ओके। हाँ यस,
वो 41 कैसे आया?
41 आप हिसाब करो ना, 90 80 में प्रिपेयर हुआ 1 जनवरी, तो 98 एक साल, 81 82 इसी हिसाब से
ओके
20
सर,
तक
वो
करो।
मेरे क्वेश्चन में गलत था, मैं 1930 लिखा था।
अच्छा
Thank you, sir.
1980 लिखा था ना मैंने।
सर
ओके
हाँ यस,
सर इस तरह के क्वेश्चन में वो लीप ईयर का एक्स्ट्रा डे को कंसीडर नहीं करते?
कौन सा?
जो 360 मतलब लीप ईयर का जो एक्स्ट्रा डे होगा,
नहीं नहीं, वो कंसिडर नहीं करते।
नहीं करते?
ठीक है, चलो।
सर आंसर 8.24 आ रहा है।
गलत आ रहा है आपका, चेक करो अच्छे से।
ओके सर।
ये देखो, इसका देखो, पोटेशियम 40 से आपका, पोटेशियम 40 ह्यूमन बॉडी में इतना परसेंट है, ठीक है, इतना परसेंट है। और ह्यूमन बॉडी का जो मास दिया है, ह्यूमन बॉडी का जो मास है गिवन, वो कितना गिवन है? 70 kg, ठीक है। एंड हाफ लाइफ टाइम गिवन है पोटेशियम का, वो आपका है 3.94 इंटू 10 की पावर 6 सेकेंड, ठीक है। तो इनिशियल एक्टिविटी कितना है पोटेशियम का, ए नॉट पूछा है।
सर ये 3.94 है,
3.94 10 की पावर 6 सेकेंड, है ना? हो जाएगा?
यस सर।
कैसे करोगे?
पोटेशियम का मास निकाल लेंगे पहले ह्यूमन बॉडी।
हाँ गुड। सो पोटेशियम का कितना मास में निकालेंगे? तो 70 kg मतलब 70 इंटू 10 की पावर 3 ग्राम, राइट। इसमें पोटेशियम कितना परसेंट है? 3.24 इंटू 10 की पावर -5%, so it will be percent, so you have to divide by 100, right?
यस सर।
हाँ, so how much it will be then? समझ में आया ना? ये इतना परसेंट है तो कितना अमाउंट कितना होगा? You have to divide by 100, right? So it will be 7।
एवोगाड्रो नंबर के लिए केजी का
नहीं
कन्वर्जन
पहले, हाँ पहले आप ग्राम निकालो, कितना ग्राम है प्रेजेंट, है ना, फिर हम नंबर निकालेंगे कितना नंबर ऑफ न्यूक्लियर प्रेजेंट है। तो 70 kg में कितना ग्राम आपका पोटेशियम है वो पहले निकालो, फिर नंबर ऑफ एटम मिल जाएगा आपको, है ना। तो 70 ग्राम।
सर ये क्वेश्चन क्या था सर?
क्वेश्चन ये था पोटेशियम जो है ह्यूमन बॉडी में इतना परसेंट है।
यस सर।
ह्यूमन बॉडी का मास कितना है? इतना है।
यस
अगर
सर।
हाफ लाइफ ऑफ पोटेशियम इज दिस 3.94 10 की पावर 6 सेकेंड, तो
Yes, sir.
इनिशियल एक्टिविटी कितना है पोटेशियम का?
ओके सर, ओके सर।
तो इतना परसेंट 70 kg का इतना परसेंट कितना हो जाएगा? 70 kg है, ग्राम में कन्वर्ट करो पहले, फिर
यस सर।
परसेंट में। हाँ ठीक है ना?
सर ये
3.24 इंटू कितना आ जाएगा ये आपका
18.4 into 10 raised to minus 3.
माइनस
-3.
माइनस कितना आएगा
4
4 आएगा, राइट, -2 देन यस -4, ठीक है। तो ये है, आप निकालो, क्या निकालोगे कि 40 ग्राम में कितना है आपका एवोगैड्रो नंबर है ना, 6.023 10 की पावर 23 है ना। तो इतना ग्राम में कितना है 70 इंटू 10 की 3.24, 7 लिख सकते हो इसको, देन 10 की पावर -3 ग्राम, राइट। इसमें कितना होगा 6.023 10 की पावर 23 डिवाइड बाई 40 इंटू 7 इंटू 3.24 इंटू 10 की पावर -3, राइट।
Sir, 6.6 into 10 to the power 13. Answer.
हाँ 10 to the power 13, yes, 6 into 10 की पावर 13.
Yes,
Okay.
sir.
So this will be your what? This will be your N naught. So if you calculate it, I have calculated, I got 3.4 10 की power 20. 3.4 10 की power 20. Now
Yes.
you can easily calculate that activity. So it will be N naught equals to N naught lambda. So N naught is 3.4 10 की power 20. Then N naught will be lambda will be 0.693 divided by T half. T half is how much? How much it was? 3.94.
Yes,
10
sir.
की 10 की power
Yes,
6.
sir.
6. So if you calculate, approximately you will get 6 into 10 की power 13 DPS. Okay.
सर ये मुझे 40 ग्राम इक्वल्स टू ये एवोगैड्रो नंबर, ये वाला स्टेप नहीं समझ में आया।
देखो कोई भी ये मोलर कॉन्सेप्ट है, इसका मास नंबर कितना है 40 है पोटेशियम का, है ना।
ओके सर।
तो ये मोलर कॉन्सेप्ट क्या बोलते हैं कि जो मास नंबर है उसका कॉरस्पॉन्डिंग ग्राम will contain how many nuclei? Avogadro number. For any given, suppose you don't know, for any mass number. So if suppose you have nuclei with mass number A, so A gram will contain how many nuclei? Avogadro number. Okay, that's what I am doing from previous class.
इसीलिए तब 1 ग्राम में इतना हो गया,
1 gram में
इतना में इतना हो गया। ओके सर।
Okay, shall I erase and go for next problem?
Yes, sir.
Okay.
Sir, 10 to the power 20 आ
10 की पावर 20 आ रहा है, ये तो 10 की पावर 20 है।
ये नहीं
हाँ।
सर, हाँ
फिर आपका
DPS.
हाँ ये आपका 6 है ना, तो इधर लेके जाओ 40, बाकी सारे फैक्टर को काउंट करो 10 पर
Oh,
30।
sorry, sorry. ठीक है,
हाँ
ठीक है, ठीक है.
थोड़ा पेशेंस लेके कैलकुलेशन करो, ठीक है। ओके नेक्स्ट प्रॉब्लम। Next problem is suppose a sample has initial activity that we don't that is not given. Okay, after 280 days. Okay, after 280 days. So days means now I'm writing D. Its activity become 6000 DPS. Okay, and same sample after 420 days, its activity become 3000 DPS. Then what is the initial activity? जब 280 डेज के बाद मेजर किया गया है इतना है, 420 डेज के बाद मेजर किया है इतना है, तो इनिशियल एक्टिविटी कितना है सैंपल का? हो जाएगा? हाँ कैसे करोगे? सो यू नो AT इक्वल्स टू A naught exponential minus lambda t. Okay, so from here you can write AT by A0 equals to how much? AT by A0 equals to exponential minus lambda t. Okay, so now if you take natural log, it will be ln AT by A0, that will be minus lambda t. It means lambda t will be how much? Ln A0 by AT. So lambda will be how much? 1 by t ln A0 by AT. So after time 280 days means lambda will be how much? Lambda will be, t will be 280. Let us write it in day itself. Now in place of AT, it will be 6000 DPS, right? Now if you lambda will not be changed for any decay process, right? Lambda remain be constant. So if when you are substituting the time, lambda will be lambda. So it will be 420. Then it will be A0 divided by 3000. Now this and this are same, right? Because lambda are same. Shall I erase this part?
Yes, sir.
So we can write 1 by 280 A0 by 6000 should be equals to 1 by 420 ln A0 by 3000. Okay, if you bring this 420 here, so 420 divided by 280 ln A0 by 6000 equals to ln A0 by 3000. Okay, this will give you 3 by 2, right? So you can write 3 ln A0 by 6000 should be equals to 2 ln A0 by 3000. Okay, so this power, this thing you can bring in power, right? No, you know, right? Ln
Yes.
x to the power n means n ln x, right?
Yes.
So what does it mean? It means a0 by 6 ki power 6000 ki power cube should be equals to a0 by 3000 square, right? So a0 square will be gone. So this side you will have a0, right? Because cube is there. So 2 will be gone. So simply a0 will be how much? A0 will be 6000 cube divided by 3000 square. Okay. So if you calculate it, I've calculated. Let me check. Calculate करो जरा, calculate करो. I've calculated it. I got 2400 DPS. नहीं, 24000.
000, yes sir.
ओके, 00 हो ही नहीं सकता, क्यों?
क्योंकि सर वो बढ़ना चाहिए, कम नहीं होगा.
हाँ एग्जैक्टली, बिकॉज 20 डेज बाद इतना है, इससे तो ज्यादा ही होगा, है ना?
Yes sir.
चलो
Yes,
इरेज
sir.
हो गया?
सर आ रहा है वही
Yes, sir.
आंसर है.
हाँ,
लिखा है. आपने लिखा है वही आ रहा है 24 into 10 raised to 3.
गुड, वेरी गुड. चलो इरेज.
Yes sir.
सबका हो गया?
Yes sir, हो गया.
हो गया, चलो गुड, वेरी गुड. क्लास स्लो फास्ट क्या हो रहा है? स्लो हो रहा है या फास्ट हो रहा है? बताओ.
सही चल रहा है सर.
सही चल रहा है?
है.
ठीक है ना?
Stop हो रहा है सर.
तो आप लोग जैसे बोलोगे वैसे चलेगा ना टीचर. चलो ठीक है. नेक्स्ट प्रॉब्लम. यूरेनियम 238 decays to lead 206. Okay, so half-life is given. Half-life of uranium is given 4.5 into 10 to the power 9 years. Okay, so they ask number of PB divided by number of uranium at time t equals to 1.5 10 to the power 9 years. So this nuclei is decays to this. Half-life of this uranium is given this. So number of lead nuclei divided by number of uranium nuclei after time t equals to 1.5 10 to the power 9 years. Calculate करो जरा.
सर टी हाफ क्या है सर 4 पॉइंट ये किसका है सर
हाफ लाइफ ऑफ
uranium
दिस
का?
डीके. हाँ,
ओके
कैसे
सर
करोगे? सो नंबर ऑफ
सर इतने ईयर में ये पूरा डिके हो जाता है 1.5
नहीं, इतना ईयर में हाफ हो जाएगा. सपोज मान लो नंबर एन
और
नॉट
ये
है.
जो नीचे
not-
टाइमिंग है
ये देखो
सर,
ये
ratio
नीचे
find
टाइमिंग
हाँ सॉरी
रेशियो फाइंड
सर
करना है.
नीचे टाइमिंग किसकी है
ये देखो ये डीके प्रोसेस हो रहा है ना, तो इसका हाफ लाइफ टाइम इतना गिवन है. ये जो क्या बोल रहा है कि नंबर ऑफ लेड न्यूक्लियाई रेशियो ऑफ नंबर ऑफ लेड न्यूक्लियाई डिवाइड बाय नंबर ऑफ यूरेनियम न्यूक्लियाई आफ्टर टाइम t goes to 1.5 into 10 to the power 9. So initially suppose you have n naught number of nuclei here, so it will be 0, right? So after time t there will be some nuclei here and some nuclei will be here, right? No, because this is decaying. Did you get what I'm saying?
यस सर
यूरेनियम
Yes, sir.
डिके होकर लेड बना रहा है, तो इनिशियली एन नॉट है, इसका 0 है. आफ्टर टाइम टी क्या हो जाएगा, इसका एन नॉट एक्सपोनेंशियल माइनस लैम्डा टी. सो पीवी कितना हो जाएगा? तो पहले तो एन यू निकालो. एन यू कितना हो जाएगा एट टाइम टी? इट विल बी बेसिकली एन नॉट एक्सपोनेंशियल माइनस लैम्डा टी. सो एन पीवी कितना हो जाएगा बताओ? एन पीवी कितना हो जाएगा, क्योंकि आपका देखो एट द एंड एन यू टी प्लस एन पीवी T should be equals to n naught, right? So this after time t, number of uranium nuclei left will be how much? Nu t equals to n naught exponential minus lambda t, and sum of this plus this nuclei, since this is stable, also mentioned it is stable, and you know this is stable. So see,
Sir.
yes,
प्लीज ये बताओ इज इक्वल टू n नॉट मतलब
इसीलिए
क्या
बोलेगा देखो n नॉट इनिशियल एटम है इसका, ठीक है ना? इनिशियल
हाँ.
नंबर ऑफ एटम n नॉट है, ये 0 है, तो नेट कितना हो गया? n नॉट हो गया, ठीक है ना? आफ्टर टाइम t लेट अस assume this number is n, okay, or let us assume this is nu, and some of the nuclei will be decays and it will create pb nuclei, so it will be npb. तो ये कितना सम nu plus npb, that should be n naught, because this pb
Yes.
from here it is coming from this, right?
clear
हाँ.
clear
Now you can write it npb. npb will be how much? Simply n naught and nu, you know, that is n naught exponential minus lambda t. Okay, so if you calculate npb by nu, it will be how much? N naught, substitute this, so n naught will be common, 1 minus exponential minus lambda t divided by n naught exponential minus lambda t. Okay, so if you multiply exponential lambda t on numerator and denominator, you will get exponential lambda t minus 1. Okay, is it clear now? Is it clear? Is it
Yes,
clear? Now can you calculate? Calculate and NB. So if you calculate it, so npb by nu will be exponential 0.693 by t half. T half is 4.5 into 10 to the power how much? How much it is given? 9, right?
Yes, sir.
10 to the power 9. 1 minute. 10 to the power 9, and t is 1.5 10 to the power 9. So it will be cancelled. 1.5. This is also cancelled. So basically you will get, and there will be minus here, of course. So exponential 693 divided by 3 minus 1, right? So if you calculate it, I have calculated, you'll get 0.26.
Yes sir, 0.26 आ रहा है.
Good.
सर ये 1.5 था कि 15 into 10 to power 9?
1.5 था, 1.5. आप करेक्ट कर लो, शायद पॉइंट नहीं दिखा होगा, है ना? बोर्ड पे कभी कभी दिखता नहीं, इतना स्मॉल होते हैं ना. करेक्ट कर लो आप, ठीक है. नाउ विल गो दैट सक्सेसिव डिसइंटीग्रेशन. दिस इज वेरी इंपॉर्टेंट फॉर योर एग्जाम. Okay, so suppose you have successive disintegration. So suppose you have A nuclei, the parent nuclei decays to B, B further decays to C, and C is stable. Okay, so this A to B, that decay constant is lambda 1, and this is lambda 2. At time t equals to 0, this number is n naught, this number is 0, this number is 0. At time t equals to t, this becomes n1, this becomes n2, this becomes n3. So obviously you can write n1 plus n2 plus n3, that should be equals to n0, right? Because this number is coming from this, right? So initially there is no B and C nuclei. After time t, it becomes n2 and n3. So this nuclei is coming from the where? A nuclei. So n1 plus n2 plus n3 should be equals to n0. Okay. So you can write like this: this plus this plus this should be equals to this plus this plus this. Now rate equation or rate of disintegration. For A nuclei, how much it will be? dn1 by dt equals to minus lambda on n1, right? Is it clear? From that basic law of
n नॉट होगा ना सर?
नहीं, n नॉट तो अभी अभी लिमिट बैठाएंगे इसको, ठीक है? So is it clear? Now if you solve it, if you bring rearrange it, so dn1 by n1, that should be equal to minus lambda on dt, right? So if you now substitute that limit, initial t at t equals to 0, n1 was n0, and at time t equals to t, let us assume that number is n on t. Okay, n on t. So if you calculate it, it will be natural log of ln, right? So it will be simply ln n on by n naught if you substitute that limit, and that should be equals to minus lambda on t. So it means n on t should be equals to how much? N naught exponential minus lambda on t. So initially, let us assume this is your first equation, this is your second equation. Okay. Now what will be that rate equation for B nuclei? What will be that rate equation? What will be that rate equation? So if you write it, see, B nuclei is decaying. So for this, that decay will be minus lambda to n2. Further, it is creating at what rate? N on lambda 1, right? A is decaying by the rate minus lambda on n on, and that is basically producing that B. So there is a production of B at rate lambda on n on, and there is a decay of B at the rate of minus lambda to n2. So what you can write, the decay rate for
These two things are taking at the same time, right?
this is happening at the same time. So it
Okay,
is
sir.
producing at the rate lambda 1 n1. So obviously the sign will be plus, right? And it is decaying with a rate lambda 2 n2. Is it clear?
Yes,
No.
sir.
Now if you bring this term on left hand side, so it will be dn2 by dt plus lambda 2 n2 equals to, this will be lambda 1 n1, right? First this one.
Yes, sir.
So you can
बताएंगे वो प्लस कैसे आया?
प्लस, इसीलिए देखो इसका रेट ऑफ चेंज देख रहा हो, तो रेट ऑफ चेंज क्या है, कितना चेंज हो रहा है इसका, तो एक तो आपका इसका प्रोड्यूस हो रहा है ना, एट व्हाट रेट, द एट सेम रेट एट डीके ऑफ ए, तो किस रेट में प्रोड्यूस हो रहा है, प्लस लैम्डा 1 n1, एंड ये डीके हो रहा है बी टू सी एट व्हाट रेट, माइनस लैम्डा 2 n2. So rate of change of this p nuclei will be how much, lambda 1 n1 minus lambda 2 n2, and you know already we have calculated that n1, that is n0 exponential minus lambda 1 t. Okay, now if you multiply exponential lambda 2 t by both sides, so it will be simply dn2, or let us break that bracket, so dn2 by dt, that plus exponential lambda 2 t lambda 2 n2, that should be equals to how much, lambda 1 n0 exponential lambda 2 minus lambda 1 t. Is it clear? Is it clear? So just
Yes,
I have
sir.
multiplied by exponential lambda 2 t. Now you see what we can write that left hand side. Can we write like dy dt n2 exponential lambda 2 t? Can we write? So if you differentiate this term, exactly you will get this term. So first you see, I'll differentiate this term first. So this will be as a constant exponential lambda to t dn2 by dt. Then I'll keep n2 as a constant in the second term. So n2 will be outside, d by dt exponential lambda to t. So it will give you lambda 2 into exponential lambda to t. It will be exactly same as this term. Is it clear what I'm saying? So just differentiation of a x into or y or a into b. Is it clear?
Yes,
Dekho.
sir. Sir, also
Yes,
this is
sir.
a linear differential equation.
Huh?
Sir, also this is a linear differential
Exactly,
equation.
exactly.
So you
So
have multiplied e to the power lambda 2 t
हाँ,
from left and right both, right?
both side, yes.
Okay, sir. तो ये
Okay.
बन गया.
हाँ.
Okay, sir.
Now it will be lambda 1 n0 exponential lambda 2 minus lambda 1 t. Okay. अब इसका इंटीग्रेशन करो. Okay. So at time t goes to 0, that number was 0, right? At time t goes to t, that number is n2. n2 t you can write. So what will be n2 t? n2 exponential lambda to t, that will be, so this is integration, means it is simply this, right? n2 exponential lambda to t, and what about this term, lambda 1 n0 exponential lambda 2 minus lambda 1 t divided by lambda 2 minus lambda 1 plus some constant. Okay. Now see, at time t goes to 0, n2 was how much? 0, right? At time t goes to 0, n2 was 0. So if you substitute in this equation, in this above equation, so on the left hand side it will be 0, right? Because the 0 into 1 equals to 0, and that should be equals to lambda 1 n0 divided by lambda 2 minus lambda 1 plus c. Because exponential part, exponential 0 will give you 1. So lambda 1 n0 divided by lambda 2 minus lambda 1 plus c. So from here you will get that c. C value of c will be minus lambda 1 n0 divided by lambda 2 minus lambda 1. Is it clear?
सर सी क्यों आया सर इसमें?
c इंटीग्रेशन का कांस्टेंट है.
सर
First-
लिमिट तो है ना
हमने
अपने पास, फिर
डेफिनेट
कांस्टेंट तो
इंटीग्रेट
आएगा
करा
ही
है ना.
नहीं. हाँ सर.
लिमिट तो है, बट कोई भी इंटीग्रेशन में आपका जब ये करोगे, इंटीग्रेशन करोगे तो आपका सी कांस्टेंट तो आएगा ही ना।
इसके पहले जो हमने
हाँ,
प्रॉब्लम
वो
किया
भी
था
उसमें भी,
नहीं लिया।
उसमें करो आप, लिमिट करो, लिमिट सब्स्टिट्यूट करो, सी उसमें 0 हो जाएगा, करो आप। उसमें बोल लो ना पहले वाला, डी एन ऑन बाई डी टी,
में किया था वो
ये
पहले।
वाला।
कल से चल रहा था ना, मतलब वो वाला।
हाँ, उसीलिए नहीं किया, वहाँ पे 0 आ जाएगा, मैं प्रूव कर रहा हूँ, आप देखो, यही था ना आपका इक्वेशन, यही था ना। This was your first, this was your first equation, right? So it is n naught, n on, right? Was it like that?
No,
Huh?
it is yeah, same है sir.
Same, right? तो इसमें लिमिट सब्स्टिट्यूट करो, t equals to 0 to t, है ना। तो सब्स्टिट्यूट जब करोगे आप पे, यहाँ पे कितना आ जाएगा, ln n on by n0, that will be how much, minus lambda on t plus c. At time t equals to 0, n on will be how much, n0. Just you substitute it here. So t equals to 0, this time will be 0. ln on by on, sorry, on, it will be 0, right? C should be 0. Is it clear what I'm saying? Did you get what I'm saying?
Yes. C was
Everybody,
0.
everybody agreed?
Yes,
Yes,
sir.
sir.
So whenever you will do now, you have to keep that constant. But I didn't keep it because this term will be 0. But for this, it is not 0. Now we substitute it here, there, C value, and you will get some number. So that will be n2t exponential lambda 2t equals to how much? So these things will be common from both terms. So you will get lambda 1 n0 divided by lambda 2 minus lambda 1. Then you will have exponential lambda 2 minus lambda 1 t minus 1. Right? Now
हेलो
if you,
सर,
yes,
सर ये जो अपने इंटीग्रेशन किया है,
हाँ,
अगर सर इसको सोल्व करें टी इक्वल टू 0 रखेंगे तो फिर भी ये माइनस लैम्डा 1 एन नॉट अपॉन लैम्डा 2 माइनस लैम्डा 1 तो आएगा ही आएगा, क्योंकि उसमें सर e टू पावर लैम्डा 2 माइनस लैम्डा 1 टी तो है ही। जब टी इक्वल टू 0 रखेंगे तो वो आएगी वैल्यू,
कहाँ पे,
वो इंटीग्रेशन में सर।
यहाँ पे,
यस सर।
हाँ, t equals to 0 रखोगे तो आ जाएगा, देखो, that t equals to 0, that should term, this term should be 0, right, n2. Now that is only possible when this c should be equals to this, which you can check it. n2 will be 0 at time t equals to 0, n2 will be 0. That is only possible when c will be this. You can check n2 into 1. Okay, this will be 0. So lambda 1 n naught divided by lambda 2 minus lambda 1 minus this. So it will be 0. If it is not, if it is suppose c is 0, then n naught cannot be 0 at time t equals to 0. Did you get what I'm saying? Is it
Yes,
clear?
sir.
Is it clear?
Yes sir.
Okay. Now can you tell me what will be the n2? N2t. What will be that n2t? Lambda 1 n0 divided by lambda 2 minus lambda 1 exponential minus lambda 1 t minus exponential minus lambda 2 t. Just I have multiplied exponential minus lambda 2 t by both sides. So this time term will be 1. Here minus exponential plus lambda 2 is here in the first term. So if you multiply it by minus lambda t, exponential minus lambda t, so this lambda 2 will be cancelled and second term will simply become exponential minus lambda 2t. Is it clear? So let us take this is your equation number 3. Okay. And third, what about n3? Anyone? So n3 will be simply you can calculate.
तो one कहाँ गया सर इसमें?
Huh? Yes.
1 minus 1.
Yes. This one. So C was something. If you take this term common, you will get minus 1.
No sir, in next last step, this question, third step.
This step.
Yes sir. Minus
Just I
1
have multiplied by exponential minus lambda 2t both sides. So this will be gone. And here you will get minus lambda 2t. So if you keep it inside bracket, so this lambda 2t will be cancelled and this 1 will become exponential minus lambda 2t. Now is it clear?
Okay,
Okay.
sir.
Now what about n3? Satan, tell me what will be the n3?
So dn3 by dt equal to lambda to n2.
No need. See, we already know n naught equals to how much? N1 plus n2 plus n3, right?
Yes, sir. Negative calculation.
So you can calculate n3. So n3 will be how much? Simply n0 minus n1 minus n2, right? Now you know everything. n0 n1 you know, n0 exponential minus lambda 1 t. And this just you have calculated, that is n0 lambda 1 divided by lambda 2 minus lambda 1. Then you have factor, right? Exponential minus lambda 1 t minus exponential minus lambda 2 t.
So
Now, yes.
सॉरी टू डिस्टर्ब सर. सर ये थर्ड इक्वेशन में क्या लिखा हुआ है लास्ट में? नीचे सर, नीचे लेफ्ट में.
थर्ड इक्वेशन ये वाला?
हाँ सर, इसमें एंड में ये क्या है? e टू द पावर माइनस लैम्डा 2 होगा ना?
अच्छा, लैम्डा 2t लिखा था वो मुझ गया, लैम्डा 2t. ओके, लिखा था वो समझाने के टाइम वो फिर इरेज हो गया. नाउ कैन यू सी, you bring the exponential minus lambda 1t term together. So this term and this term is exponential minus lambda 1t, and this term is exponential minus lambda 2t. And you say n naught is common from every term. So n naught is outside minus, if you take exponential minus lambda 1t common, exponential minus lambda 1t अगर common लोगे तो फिर क्या मिलेगा आपको? 1 plus lambda 1 divided by lambda 2 minus lambda 1. And what about that your lambda 2 term? So it will be lambda 1 divided by lambda 2 minus lambda 1, right? And exponential minus lambda 2 t. So it will be simply n naught on minus lambda 2 divided by lambda 1 minus lambda 2 minus lambda 1, exponential minus lambda 1 t. Then you have lambda 1 divided by lambda 2 minus lambda 1 exponential minus lambda 2 t. Okay, is it clear? Is it clear?
Yes,
Yes, sir.
Okay, now can you draw this diagram?
सर n3 मत रखो.
हाँ,
n3 मत रखो.
number of nuclei, number of C nuclei. शुरू में ध्यान दो, शुरू में तो डिफाइन किया था ना, टाइम t इक्वल्स टू t n3 इज नंबर ऑफ C nuclei. ठीक है ना, शुरू में ये डिफाइन किया मैंने. चलो ठीक है, अब इसको प्लॉट करो जरा. तो विल प्लॉट 3 n1 n2 and n3 with time. ओके, सो n1 का प्लॉट कैसे होगा? इस तरह से होगा, एक्सपोनेंशियली डीके. ओके, n2 का प्लॉट, सो दिस इज योर n1. n2 आपका किस तरह से होगा? दिस इज योर n2. and n3 will be this is your n3. So can you calculate the time at what time n2 becomes maximum or number of B nuclei is maximum? Can you calculate that t prime? So t prime is represent the time at which n2 becomes maximum. Can you calculate? So I will calculate. Shall I erase this part?
yes, sir.
So if you remember, n2 was how much? So last equation, you please mention that last equation is equation number 4. Okay, I forgot to mention. Now you know n2. n2t is how much? It was n0 lambda 1 divided by lambda 2 minus lambda 1 exponential minus lambda 1 t minus exponential minus lambda 2 t. So n2 maximum means
dn2 by dt equal to
exactly dn2 by dt 0. Okay, it means n0 lambda 1 divided by lambda 2 minus lambda 1, and this term will give you minus lambda 1 exponential minus lambda 1 t plus lambda 2 exponential minus lambda 2 t, that should be equal to 0. since this term is not equals to 0, these are all are non-zero
Sir.
quantity. Yes, इसमें भी प्रॉब्लम है क्या?
नहीं सर ठीक है.
ठीक है, आप इसको करो, कैलकुलेट करो. So this term is not non-zero. So
Sir.
this, yes,
Yes sir.
this term
1
should be
upon
equal.
lambda 1 minus lambda 2.
हाँ, yes. So it will be
lambda
lambda 1 exponential minus lambda 1 t should be equals to lambda 2 exponential minus lambda 2 t. So it means lambda 1 divided by lambda 2 should be equals to exponential lambda 1 minus lambda 2 t. Okay. So it means t equals to how much? If you take that natural log, so it will be
1 upon lambda 1.
lambda 1 by lambda 2
Lambda 2.
divided by lambda 1
upon my
lambda
minus
2.
lambda 2.
So this is t prime, right? This is t prime. I have defined. Okay. Now equilibrium. Okay. So already you have time finished, right? Time is finished now.
Yes, sir.
Yes sir.
Okay, well, tomorrow we'll discuss then.
Thank you sir.
Is there any question?
सर इसमें n3 के ग्राफ में it is increasing and becoming constant.
Yes, at the end n3 is producing, right? All are decaying. ठीक है ना, सारे decay हो गए at the time. इस क्या होगा, n2 में
n3
जमा
को contribute कर रहा
हाँ
है.
सारे है ना. Okay, so I should stop here. Okay.
Okay, sir.
Okay.